Welcome to Chapter 3, Network Security. So we're going to cover, again, I'd like to say light touch as it relates to key components of the examination as it relates to Security Plus you should be aware of. We're going to talk about the introduction to network security, security network infrastructure, firewalls, intrusion detection and prevention systems. We normally call those IDS, IPS. Virtual private networks, VPNs, secure communication protocols, wireless security networks, and network access control. So let's talk about just definition as it relates to network security. Now, again, I say light touch when I come out with the Network Plus security training. That gets into the technical aspects of things. So just from a definition perspective, network security really involves policies and procedures to really prevent and monitor unauthorized access, misuse, modification, denial of computer network accessibility, resources, etc. I talked about in Chapter 2 about the CIA, ensuring the integrity and confidentiality and availability of the data and the resources. Your network security is really part of that tower and pillar that's going to help support that. Again, related to those policies and practices that you want to put in place for it. Again, that's the textbook definition. That'll probably be in an exam. You want to make sure you understand that. Now, when we talk about securing your network infrastructure, there's different components to that. You have your routers, your switches, firewalls, and your endpoint. Again, this is just important to know the makeup of it. The technical aspects of this we'll cover more in the Network Plus course that I'm creating, or will have to be probably created by the time this gets rolled out. Some best practices just to keep top of mind. Strong passwords and change them regularly. Regularly update your firmware and software, and you want to implement what we call network segmentation. Just be aware of these are the best practices. The Network Plus will get into this a little bit more detail. When you think of your definition of your firewall, so your firewall is just basically, as it stands here, a network security device. That's all it is a device that monitors and is going to filter out incoming and outgoing traffic. Think of it like a highway and a toll gate, if you think about it. You got to stop at the toll gate, pay some money, but maybe you don't have enough to pay, and then you might be some restrictions. But think of it like that. It's a gate you have to go through back and forth. And it's going to have some checkpoints within those toll gates. So basically it's going to say, yep, you're traveling from east to west. You could either go there or you can't go there, because maybe only blue cars are allowed to go from east to west. Or only red cars could go from west to east. So think of it as a gate that has basically guidelines on how you're going to travel back and forth. Now, there's different types of how that happens. You have packet filtering firewalls. You have stateful inspection firewalls, and you have proxy firewalls. Again, because this is more of a light touch of how we're covering it from a definition perspective, just be aware that a packet filtering firewall is just going to examine packets, either block them or allow them. So really, I like to think of it as it's going to look and see. You remember that toll gate I said? It's going to say, okay, yeah, you got enough people. I think I agree with those folks. I'm gonna let you go. And you might say, oh no, there's some issues here, and I'm not allowing you to go through that gate. Then you have what we call stateful inspection firewalls, right? They're gonna track the state of the active connections. Is it strong? Is it good? It's just kind of tracking that. And then it's going to look at the next one is proxy firewall. It's a filtering of the network traffic at what we like to call the application layer. I don't want to get into too much detail around this, but you're going to hear something about the OSI layers. There's 7 of them. Again, I'll cover that in another course. For this takeaway, just be knowledgeable and be able to answer questions if it says, okay, what does the Pactful filtering firewall do? And it'll list some answers. And then you just kind of name them from that perspective. Now we're going to get into a little bit about intrusion detection and prevention system, IDS, IPS. So in its kind of basic definition form, your IDS is going to basically just monitor the traffic for suspicious activity. It's going to basically create an alert. So if it sees something that doesn't seem right, it's going to say, hey, we got an issue here. You need to look into it. So that's what we call a detective control, I like to say. And again, that's a little bit more, but that's really, think of it from there. IDS is more about detection. It's not preventing anything. Just keep that in mind. Your IDS does not prevent anything. It's more like a looky-loo. And then when it sees it, like reports it. See something, say something. That's that concept. Where your IPS, it's going to detect and it's going to take action. So it might just say, oh, I know what you're here to do. And you know what? You're not doing it. We are locking you up. We are shutting you down. You are not going anywhere. So again, key thing to remember for the examination. Detection is just, that's all it does. It's just looking. But it ain't doing anything to stop it. Prevention is going to detect and it's going to take action. So not only are you going to say, hey, I see what you're doing. And you know what? It's not in line with what we feel is comfortable. So we're taking action. And that action might be taking a system offline, quarantine what it's detecting, and then putting it somewhere so it can't do any more harm. Okay, that's kind of how I like to describe it. Now, your implementation of your IDS and your IPS is really deployed at those key areas of your network where you want that maximum coverage. So you have to determine where within your network, where within your perimeter of your network do you want to put those items in terms of either just simply monitoring or detecting. And then that's the kind of the backdrop of implementation. Now we're going to move on to virtual private networks. These are what we like to call VPNs, where it really creates a secure connection over a less secure network. Again, such as your internet. You could be in a public place where you're using a public Wi-Fi. Now, there's different types. There's a remote access VPN, which is going to allow an individual user to connect to what we call a private network. Or it might be what we call site-to-site, which is going to connect an entire network to each other. So what is the benefit? It's going to ensure a secure remote access, and it's going to protect the transmission of that information within the ecosystem of how it's connected. Okay, so be familiar with the definition, understand there's 2 types, and what is the benefit of it. Again, I think of it like an internet cafe. It's a public Wi-Fi, but it's going to secure it in a way that's going to put another layer, a wrapper around that to make sure the data and how it's transmitted is protected. So let's talk about some of the secure communication protocols building on top of what I just spoke about. So you have these protocols, which is SSL and TLS. Anything where you see S normally is a secure socket layer, transport layer security. It is a secure protocol that is going to ensure that it's done in a way that's going to secure the transfer and the communication of that file. It's again sending your information across the internet highway, and basically no one in theory could just simply spoof that information and see what it is, because it's done in a way that's around a secure layer. If you think about HTTP, that's kind of where we were before, a little, dating myself. And there might be still some HTTPs out there. That was always that was not secure at all. But the moment we came up with the S, the secure protocol, the HTTPS, now adds another layer of security around that. That's why I like to say, anytime you see something with an S, SSL, TLS, generally it's a secure layer of a protocol. You have IPSec, which is again an Internet Protocol Security, and you got SSH, which is a secure shell. That's why I said that's my way of kind of saying, oh, anytime I see something with an S, 9 out of 10 times, it's a secure way of looking and browsing, secure file transfer, secure communications. It says use case. It's always a use case for me. I never not recommend we do anything without a secure method of doing it. Again, this is just from my perspective. Let's talk about your wireless network security. The great thing about wireless is wireless. That's kind of the great thing about it. But it comes with its own issues that you have to make sure you're protecting your organization from, your own self from, which is really eavesdropping, what I like to call rogue access points, and man-in-the-middle attacks. If you think about what is eavesdropping or rogue access points, I like to think of that more from a airport Wi-Fi where it says free, or people will put up like free Wi-Fi, and you will believe how many people just click on it, where it could just be someone setting that up just to get your information. It happens all the time. And then, of course, the man-in-the-middle attack. These are just concepts I want you to be aware of. We'll get into that a little bit more. And just remember, the videos I'm also incorporating into the training kind of goes into a lot of this in detail. So hopefully between the videos and then me following up with some of my own explanation, you're really getting a good understanding of what these things are. Best practice, you want to use WPA3 encryption. You want to disable SSID broadcasting, and you want to implement MAC address filtering. Okay? From exam perspective, just be aware these are the best practices as it relates to the threats. Next, we're going to we're going to talk through network access control. That you hear it as NAC. So the definition is, it's really a method that's going to really strengthen the security of a network. It's going to restrict the availability of network resources to endpoint devices. That is going to comply with a defined security policy. Right? So you're going to set up policies, and your NAC is going to strengthen that by restricting the availability of the network resources as you had it configured. It's going to control 3 areas. It's going to control authentication, authorization, and what we call accounting, AAA, the 3 A's. So why we would use that? It's really for the benefits to ensure only authorized and compliant device access to the network. That's the real reason. You want to make sure before this device is connecting to the network, does it meet all these conditions that I expect it to have? If it doesn't, then you kick it out. right? So that's kind of the foundation as to why you have that schedule and set up. So I've covered basically a lot of things, again, kind of in more focused to the exam and some of the questions you're going to get. Again, it won't be uncommon to see some variation of this is, what are some common network devices used in IT environment? Why is secure network design and configuration important? List 2 best practices for securing a wireless network. And what is the purpose of a network segmentation? And kind of, here's your answer. Again, I can't say this particular answer will be, this question will be on the exam, but some variation of it will. And I have here common network devices include routers, switches, firewalls, intrusion detection systems, and intrusion prevention systems, IPS, IDS. Why is a secure network design and configuration important? Again, secure network design and configurations are important because it's really preventing the sensitive data, preventing unauthorized access, and ensuring the overall security of the network infrastructure. List 2 best practices for securing a wireless network. The 2 best practices for securing a wireless network are using strong protocols like WPA3 and regularly scanning for rogue access point. What is the purpose of a network segmentation? The purpose of a network segmentation is to improve security by isolating different parts of the network, limiting the impact of potential breaches, and reducing the attack surface. Glossary of terms. Again, more definition. Please study these. Some parts of this will be in the examination. And even if it's not, sometimes the questions, if it says a router is used to blah, 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 at least you understand what a router is. And if the question doesn't relate clearly to a definition of the router, then you can say, okay, well, that's not the answer. So a router, a device that forwards data packets between computer networks. Switch, a device that connects multiple devices within a network and directs data to its intended destination. Firewall, a security system that controls incoming, outgoing network traffic based on predetermined security rules. Again, VLAN, WPA, rogue access point. I'm not going to read everything here, but my intent is make sure, again, based on the videos I've been showing, you read through the definition. Please study these points. And then from there, you should be able to, when you see some question about VLAN, you see a question about WPA or rogue access point, you should be able to address it accordingly. All right, as usual, if you have any questions about anything I've covered, need more information, more illustration, just send me an email. I have no problems responding out to anyone who's bought my course, and we could take it from there. Thank you.